Another thing about the way I'm recording, just so you get, this is why I don't want you guys to show up in the videos, because you, like I can record without you knowing. So I don't want you to show up in videos when you don't even know that you're being recorded. In the Google Meet, it shows you that the meet is being recorded. So that's why I tried to do it that way, but it's, I don't know what to tell you. It's just the quality of the videos is garbage. So we're going to have to do it with YouTube. And for that reason, I'm going to try to keep you guys off. Now, I don't mind if your voice shows up in the audio. That's not a big deal to me. But I don't want your face or anything that you're doing to show up in there. Okay, so in this problem where we're launching the thing at a 56-degree angle, the first thing that I would need to do to solve anything, I literally cannot solve anything until I find out the components of this velocity. So that means there are the two components. So I'm going to draw the velocity vector over here, and I'm going to draw my two components. Okay, now I'm doing this as a separate step. Now I'll leave it up to you as to how you want to do this. I could drop down into the two columns over here and do it right here. But what I'm going to do is this as a separate step, because listen, here's the thing. If this was like a real world problem, would I care what the vertical velocity was? No, I wouldn't give a crap one way or the other what the vertical velocity was. I would never even ask the question, hey, what's the vertical part of the velocity? I would never ask that question. I'm only answering this question about what are the components of this velocity because I have to have it. Because there's no way for me to separate the problem until I separate the vertical and the horizontal from each other. So I know that the x is going to be 15.6 times the cosine of 56. And I know that the y, I'm not specifying the property. I'm just taking this vector. Could be velocity, acceleration, displacement, force, momentum. Could be all kinds of things. Doesn't make a difference. It's just generic math. I'm just doing the generic math right now. 15.6. The y component is opposite from the angle, opposite the angle. So therefore sine of 56 degrees. Okay, I need everyone to do this right now in your calculator. Make that calculation, and please share the answer in the chat. And what I want to see is at least two people show me that they got the same answer, so that I know that we have the right answer and we can move on. Let's all take a moment, and you can just throw it in the chat.
X, I got 8.72, and
good.
Y, I got 12.93.
All right. Thank you so much. I appreciate that. I see that we're getting consistent results. So now we won't have a mistake because I do that all the time. I make mistakes all the time in the calculation. I hit a wrong button and I'm trying to think of like 100 things at the same time, and then it's a big mess. So I just want to really try to avoid those big messes. All right. So I feel pretty confident we got the right numbers. Notice that when I wrote it up here, I didn't say anything about the units. I didn't even say anything about that. This is a vector diagram. That's all it is a vector diagram. So up here, I'm not breaking it up into physical properties. I'm just taking this vector and breaking it up into two components. Now that I've done that, now I want to give those numbers context because they don't mean anything right now. They're just random numbers that don't have any context. So the x is going to go over on this side. And the y is going to go on, oh, I didn't even do this. I'm so sorry. I meant to put that first. I'm so sorry. I don't know why I did that. Yeah, you want to label those, of course, right? We're making two separate, right? Because this is the whole idea behind projectiles. The vertical motion is independent of the horizontal motion. Hence, this is like a logical thing to do. Let's separate them. Let's actually put a boundary between them. Let's not call it a wall. Let's not call it a wall. This is called a boundary. There's a boundary between them. And the only of the properties that can go back and forth across that boundary or across that border is the time. Because the time that it was in the air vertically is also the time that it was projecting forward in the horizontal. Okay, so now we're done with that first part, right? This is the answer for part A, right? And that's all you would need to do. Now over here, I didn't call this the initial velocity, but I see a lot of times in books they do. I think that's not a good way to do it because when you say that's the initial velocity, it implies that the velocity is going to change, but it's not going to change, right? That's the whole idea behind projectile motion. It does not change. The horizontal velocity does not change. So I have everything that I can get from the x direction. There's no other information given about this problem. But because I know that this is a free fall problem, the fact that there is vertical motion with an object freely moving, not being held by anything, it's not guiding itself, it's not an airplane, there's no motor, it is just freely moving under the influence of gravity. I know a couple of other things. So first of all, I know that the acceleration would be negative 10 meters per second squared. Okay, and that is really the only other thing right now that I guarantee you I can use in any problem, that piece of information. Okay, now before I go any further, we need to figure out, well, what are we looking for? Like, what exactly do we want to see as to what information am I going to go for? So let's say, for example, their question, the only question they ask, maybe the only question they ask is, what was the maximum height? All right, well, one thing I know about the maximum height is that the final velocity would be 0. And I really want to emphasize this, so listen carefully. I'm not saying that the total velocity is 0. I'm not saying that it's not moving. It's moving for sure. It's not moving vertically. At the top of the motion, it is now moving perfectly horizontally, so there is no vertical motion. Therefore, the final velocity would be 0 if I was looking for the maximum height. If all I cared about was the maximum height, I'm not going to say that the final velocity is minus 12.93, which is totally true. When it lands over here, the final velocity in the vertical direction, again, only in the vertical direction, is minus 12.93. But if I'm trying to figure out how high did the thing go, well, what good does that do me? Because it didn't reach, it actually has no height, right? When the velocity was minus 12.93, it was back on the ground again, so it didn't have any height at all. It was at the midpoint, right? And at the midpoint in a symmetric situation like this, because it's level ground, then I know two things. I know the vertical velocity is 0 here, and it's negative 12.93 here. Now, let me go to question B, and let's see where we need to go from this. Because at this point, I need to have a specific question. There's no more generic information that I can pull out from this problem. It says, determine the hang time. So, a couple of pieces of information. I do know that the final velocity is 12.93, but it's negative. Oops, I almost put squared there. I'm so sorry. And I also know that the final displacement would be 0. Okay, that's basically everything. There literally is no other piece of information other than the time. So since part B is asking about the entire motion, this is my given information. This is going to let me, any answer that has to do with the entire motion, this is going to let me solve it. So let's go through and solve this problem now. We have some options about different equations. So I am looking for t. I would tell you this. I would use this equation. But let me show you the 3 equations that you can choose from. You could do this. D equals crap. Plus V naught t. I don't know why I did that, man. My brain is really broken today. That will work. That will work. I can get the time from that. It's not easy. It's actually going to be a mess. It's going to be quite difficult. But you can do it. It's definitely possible. I could also use this. V squared equals V naught squared. Oh, no, I can't use that. No time. D is equal to 1/2 P plus V naught times T. That'll work because I have all that information. That's better. I mean, that's definitely better because, look, it's a much easier equation. There's nothing squared. That is definitely going to work out a little bit better. But here's the problem. Here's the problem. It won't actually work in this problem if I do it the way I'm doing it right now, because what's V plus V naught? Well, that's 0. Right? So if I look at the total motion, there's 2 ways to achieve that. At the beginning, the displacement was 0. When time was equal to 0, that's true. When the time was 0, look, if I plug in 12.93 and minus 12.93, I get 0, and that's when the displacement is going to be 0, so it doesn't matter what the time is, right? But the reason why that's true is because when the time was 0, the displacement was 0. That was the beginning of the motion. But also later it was. So that equation's not going to work. Even though I have all those properties, it's not going to work. This equation will work, but I would say it's not a very smart choice when you could have chosen this. That's so much easier of an equation. There's nothing squared. There's very little to do. So that's where I'm going to go with this. T is equal to V minus V naught over A. Oh, I'm sorry, move up a little bit. Now here's where keeping track of those positives and negatives is so important. You can understand everything about this problem and miss a negative sign and get the answer completely wrong. And obviously that's what we want to avoid, right? We really want to avoid that. So my final velocity was minus 12.93, and my initial velocity was 12.93. So let's just take a look at this and make sure this is really clear. That negative sign is there because the property itself is negative, as I've already identified. It was moving down when it landed. So the velocity in the vertical direction was downward. That's why this V has a negative sign in front of it. This guy has a negative sign in front of it because of the algebra. The algebra says that I need to subtract these two in order to find the difference here. So that negative sign is not because the 12.93 was negative. It's not. It's actually positive. But there was a negative sign in front of it. So what I'm going to end up with is 2 times negative 12.93. And that will all be divided by minus 10. So a couple of things to notice. First of all, I'm going to end up with double the velocity on the top. Okay. And secondly, the negative sign is going to go away. The negative sign will go away because I'm going to have a negative number on the top, a negative one on the bottom, and that's going to give me a positive answer, which is good because we should never get a negative time. Negative time is not physical. That's not a thing that's real. So if you get an answer for time that is negative, you probably just missed a negative sign somewhere. Most likely, you missed the negative sign on the acceleration. That's frequently, people just, they say it in the given, and then when they plug it in, they just put in 10. But it was really important in this problem, because we went up and down, that we kept track of the positives and negatives. And I know that's what makes these so difficult, is when you go to where you go away from the horizontal projectile, where everything is just moving in either sideways and down, to something moving sideways but going up and down, it makes the math harder, for sure. But it's just an issue of keeping track of who is pointing up, who points down. That's it. That's all you have to keep track of, and everything will just work out. It will just naturally work out. Could I get in the chat a couple of people to tell me what this answer is? Oh my gosh, look how quick Danielle was. She's like a ninja with her calculator. Can we get one more person to just confirm? All right, good. 2.59, I'm sorry. Let's do 2.59. We will go over the rules for significant figures, so don't stress about it right now. Don't even worry about it. I'm not taking any points for sig figs at all. I'll explain why I cut that off when we talk about sig figs. And the answer was positive. Anybody have any comments or questions about this before we move on to the part C and D? You can throw it in any time. You're not interrupting me. Even if I start talking, just go ahead and throw it into the chat if you want to. Part C says, calculate how far away the ball landed. Oh, great, because that's also looking at the entire motion. So I don't really need to like reset anything. Everything is already ready to go. Nothing's really changing about this problem yet. The one question that's going to force you to have to go back and rethink your given information is if they ask you about something that occurred not at the beginning and not at the end, but instead like at the middle. Like for example, how high did the thing get? Which it looks like is the part D of the question. Okay, so at this point I don't need to reset anything. I just need to continue forward with the information that I've already got, and I need to transfer this guy over. So I just put a little arrow taking this guy all the way up here, and even though I was not originally given that information, I have it now. And that is just as good as if it had been given to me. Doesn't matter how I got it. I've got it. It's accurate. That's the right time. It was moving horizontally for 2.59 seconds at 8.72 meters per second. Therefore, D is equal to V times T. And this is so, I swear to God, it's so important. And every student still struggles with it all the way to the end. You have to distinguish between whether objects are accelerating or whether they are traveling with constant velocity. It's a different set of equations. I can't use D equals V over T on this side. I cannot use D equals V over T on this side. It's accelerating. It's not a valid equation. That is an invalid equation. Just like on this side, I cannot use D is equal to 1/2 AT squared plus V naught T. That's also not going to work because it's not accelerating. It's not a valid equation. It's not designed for that situation, and it will not give you a valid result for that situation. So this is a great place where we're putting this extra emphasis on distinguishing between constant velocity or constant acceleration. And which equations do you use depending on whether it's accelerating or not? That's a question you must ask yourself. Is it accelerating or is it traveling at a constant velocity? Now, one thing you should never say, and I know a bunch of you are going to say it anyways, even though I'm telling you right now not to say it, is don't ever say that the motion is constant. The hell does that mean? The motion is constant acceleration or constant velocity or constant position. The word constant has no meaning by itself. It means nothing, literally means nothing if you don't connect it to something, right? Like if I tell you it's constant, what am I talking about? You have no idea. You have no idea. I was talking about my weight. No, I'm not. I was talking about my income. No, I'm sorry. I was talking about the height of my children. Like it doesn't have any meaning by itself. So I'm belaboring this point because I've seen it so much in other students. They constantly tell me, oh, it was constant. It was constant. It was constant. That's never going to be the answer. It will never, ever be the answer to the question. If you can't specify what is constant, then you don't have an answer to the question. Then you do not have an answer to the question. On the left side, the velocity is constant. On the right side, the acceleration is constant. So we are basically done with this problem now. That is d is equal to 8.72 times 2.59. And if somebody could just throw that into the chat, I'll put that in there. And that'll be the end of this problem. And it looks like we're close enough to asynchronous that I'm going to let you go at this point. And then if anybody wants to look at some of those other problems, I'm happy to stick around with you for a little bit. Lisette says 22.58. Do we have confirmation? Yep, looks good. Oh, interesting. What's the number after the 8? Is there a number after the 8? 4. Okay. So that's going to be. Oh, you guys, you put so much in there, the answer disappeared off the screen. 22.58. Okay. Let me say this because we don't have enough time. I do want to let you go to asynchronous time, but I do want to respond to the other question. The only difference with that question is this guy is not negative 12.93, and this is not 0 anymore. I mean, obviously it's not 0. How could the maximal height be 0? That doesn't even make any sense. So the d is not 0, and the v is not negative 12.93. The v is 0. The v is 0 because there's no longer any vertical motion at the top. So once you have that information, you have the initial velocity, you have the acceleration, you have the final velocity, you're looking for d. You want to use the equation that I started to write right here, v squared equals v naught squared plus 2ad. And that will allow you to solve for the d, and you'll have the answer. Now, what's another option? You could use the first equation. You could use this guy. But in order to do that, we would have to know the time. Okay, but I do know the time. Can somebody in the chat tell me what the time was to reach the maximum height? Just go ahead and put it in the chat right now. Interesting. Thank you, Luis. 1.3. The time is 2.6. The point where it reached its highest was exactly at the halfway point. So yeah, 1.3 or 1.4, either one of those will be fine with me. That's an alternative way, and that would allow you to use the first equation. So now you could plug in that time in the first equation, and it'll give you the right distance. I would encourage you, why don't you try both methods and make sure that they give you the same answer? Because if one of them gives a different answer, that would indicate that maybe you have some mistake or there's some flaw in what you're doing. I know I didn't get to all the questions. I mean, I realized that we didn't get a chance to look at everything. I do feel like the projectiles is the most important part of what we did because it's on the test for sure. I don't always see relative velocity. I don't always see relative displacement, but I pretty much always see projectiles. It is always going to be there. So that is definitely the topic. That's why we did the velocity stuff. That's why we did the displacement stuff. It was to get to the projectiles and have the projectiles make a little bit of sense to you. So I would definitely put most of my emphasis on the projectile stuff, and then you will also see at least a few problems involving displacement and also maybe 1 or 2 problems involving velocity. All right, so tomorrow is the quiz. You'll have the entire period to work on it. I don't expect you to answer every question on the quiz, but I do expect you to choose wisely those questions you feel like you understand and give me as much information as you can to show me your solution. Remember, and I feel like this is for most part, most of you seem to understand it, but I still see a few people. It seems like you don't understand. I'm not asking for the answer. I am asking for the solution, and that's a difference because there's the answer, okay? There's the solution, right? Showing the work. No, the quiz is on displacement, velocity, and it's on everything basically. Because what we're doing with projectiles is what we've been doing since the beginning of the school year. It's just combining them together, right? Which is like, that is different because we looked at them separately before. So the quiz is, there will be displacement problems, two-dimensional. There will be two-dimensional velocity problems, but the majority of the problems will be projectiles. You'll definitely see one of each of the, like a good variety of projectile problems. Because here's the thing, if you can answer the projectile problems, it means you understand the vector stuff. It means you do understand the vector stuff if you can answer the projectile problems. So projectiles is a great way for me to kind of just combine it all together to see what you can do. All right, I'm going to stop my recording now. I'm going to post that. Like I said, it seems like it takes about